Hi, in this episode we are focusing on a unique benefit, the flexibility of the UWT platform. In the previous demo we have seen a typical automotive infotainment system with many RF antenna lines. Employing a high channel count RF frontend for a parallel multi-DUT testing leads us to an important question. How many transceivers do we need? UWT has a great answer. Usually the number of transceivers is defined by the number of RF ports on a traditional instrument. Using the UMX port module and UWT Instrument Software, the decision is yours. Based on the test specification and throughput requirements, you can choose 1, 2, or even 4 NI VSTs to enable true parallelism and reduce execution time. An autonomous concurrency manager will allocate instrument resources to a certain measurement or generation request to the RF port automatically. So adding or removing a transceiver is just a matter of software configuration. For instance, you can start with the UWT 11 configuration during pre-production, then add another VST to increase throughput during the ramp-up. Another option is to reuse VSTs from other locations if resources free up. These are all possible without major hardware rework. After inserting the second VST into the PXI chassis, I connected its generator and analyzer ports to the UMX. All I need to do now is to change the system configuration. I'm selecting UWT 21 from the predefined options and activating it. I'm running the same NI test and sequence that I showed in the previous video, without literally modifying any parameters or resources in the test software. Under the hood, UWT-IS is using the updated configuration, and now both VSTs get employed as you can see on the UMX software panel. Let me show this other informative UI, the scheduling chart. In the client view, you can follow the incoming measurement and generation requests for each port. The color codes indicate the type of activity, such as measuring LTE or playing a GNSS waveform. At the end, this can help you follow, debug, and optimize your high channel count parallel test program. Changing to the instrument view, we can see how much our transceivers are occupied, already showing 2 lanes for the 2 VSTs. The less idle time we see here, the more efficiently we use the most expensive components of the test system. The flexible system configuration allows other benefits too. For instance, you can minimize downtime during calibration or maintenance in a multi-transceiver configuration. Knowing that a simple reconfiguration in software is enough when adding or removing components, it is possible to operate the production line uninterrupted and calibrate transceivers one by one. Now we have an idea about the flexibility with the number of transceivers, but the UWT platform is also scalable in the number of RF ports. So I'm going to show that in the next video. Stay tuned!